Hello everyone, now I'm gonna show you the fourth experiment for UNIX Lab, and it is just numerical conversions of bit 4, which is from binary to decimal, then binary to hexa, then decimal to binary, and hexadecimal to decimal. So I'm gonna show you how I did binary to decimal. So binary to decimal is nothing but you get a binary values from 0 to 1, and if it's you multiply the each digit starting from the unit digit to the power of 2 power 0, then increment with 2 power 1. You go to the next digit to the left, then it's 2 power 1 into the 1 if it's 1, or 0 if it's 0. Then you go to the left, then it's 2 power 2 into 1 or 0, then you go to left until you find the last digit. So get a value from the user, then if the value is not equal to 0, then I store the decimal value as 0 first and the power as 1 initially. Then I go to the while loop again, then if its binary number not equal to 0, I find the remainder of that means remainder of the binary number is the last digit. So find the digit, then I add it with the multiply and the remainder of the power. Then I multiply the power with 2. Then I increment the power. Then I increment the power. Then I decrement the binary value and remove the binary value. I remove the last digit of the binary value and I print the number. As such, binary to decimal. So binary I give 1010, which is decimal value is 10. Now I'm going to show you decimal to binary. Decimal to binary is nothing but you divide by 2 and you find the remainder. If it's 1 or 0, it's going to be either 0 or 1. So you keep doing it until the last digit, until there's no other number left to divide it with, and you get the sequence of the number from the bottom of the LCM 3. So here I get the user, I get the value from the user, and initially the binary value is 0, and if the decimal number is not equal to 0, then I take the remainder, then I add the remainder to the binary value so that it comes in a sequence. Then I eliminate the last number and I print the binary value. So as such, decimal to binary, I enter decimal value 30. So here I got 4 ones and 0, which is 0 0 2 4 6 6 plus 8 6 plus 8 14 14 plus 16 is 30. Now I'm gonna do hexadecimal to decimal. So hexadecimal to decimal is you divide each number with 16 and you get the binary value of it. Hexadecimal, you take the number, divide it by 16, get decimal value, but binary value to decimal. You multiply each power with 16 from starting from the right, extreme right, and keep going to the left, and each power is started from 16 power 0, and you go to the left 16 power 1 into the value in that position, and you get a decimal value. So hexadecimal to decimal, enter a value 53, which gives in decimal format as 83. Now it's binary to hexadecimal. So binary to hexadecimal is nothing, it's going to be big programs. I use O-base and I-base. I-base is the value to which I wanted to convert. I'm going to get an input from the number, the base of the number, and O-base is the output of the value which I want, which is a 16. So I take the value from the user and I convert it using I-base and O-base. As such, V comma H. So enter a value of 32 and the hexadecimal value is 3.